So hello everyone, I'm Shiran Golan. I'm a data science team lead in Zencity. I'm gonna present you today some tools for increasing data annotation quality. My lecture is dealing with data from a more data science perspective. So let's see how can I help you with these tools. Let's talk about data. AI systems today are made of code and data. We have two main approaches to improving models and machine learning pipelines. We have the model-centric approach and the data-centric approach. The model-centric approach means we change the model, we play with the type of the model, with the architecture, we change the code in order to improve the performance. This is where the fun is. This is where everyone wants to play around and try new things. 99% of the academic publications are doing model-centric developments. And there is a lot of focus on this area and has been in the last years. But it seems that most of the current improvements of models are actually can be gained by using a data-centric approach, which means improving the data by and the inputs and the outputs, which means the labels, in order to improve the performance. As Andrew Neg mentioned in his lecture, MLOps on March last year, 2021, your model architecture is good enough. Many people in the academia worked on them and created multiple tools there and architectures. So it's complex enough, and you better focus on your data. So at Zencity, we were able to leverage using data-centric approach and gain accuracy and performance of our models. A little bit about Zencity. We have many kinds of clients, cities, counties, and law enforcement agencies, where we collect data from Facebook, Twitter, local media, and surveys. So we collect data for these kinds of clients, and we present analyzed and enriched data in our dashboard. We enrich the data by finding which category each item is associated with. For example, you can see in the slide, we have a piece of text from Facebook. We can say which category best suits this piece of text. A sentiment model will say if this piece of text is neutral, negative, or positive. And we can also extract locations. We have different models in our system. This is some examples for you to understand what we do. So as you can see, we work with a lot of data from different sources. We need to be able to annotate data to train our models and have a good performance for our users. So since the beginning of time, Zencity actually used human in the loop, meaning we have human labelers, human annotators to annotate our data for different tasks, for example, sentiment or categories. And the goals for human in the loop, I see it as two main goals. One of them is assuring user experience. In order to assure user experience, we can have label validation in production. So in the beginning of Zencity as a small startup, some models weren't that good yet. We didn't have data, we didn't have all the domain knowledge we have today. Some models weren't as robust, and we had like very few clients we wanted to impress and to make sure the data that we get is indeed correct. So as you can see in the diagram below, if we get a data item and we send it to a model prediction, then we don't show that yet in the system. We have human annotation to make sure the label is correct. And then the annotator can approve or change the label, which is presented for the users in the product. So this is one use for human in the loop. Today, we don't use that anymore because our models have developed and are better. But this is a very important use case for human in the loop. An additional option is to monitor the models. So as a daily task, we can see what is the model performance on some of the data that was collected today. An interesting use case here is that when COVID started 2 years ago, the discourse changed. Some new terms appeared, like vaccines and quarantine, and the model performance over the new data was lower. So we were able to see it in our monitors and act accordingly and adjust our models. So this is for assuring the user experience. An additional thing we can do after we have annotated data, we can of course improve our model's accuracy. We can retrain the data with up-to-date data, the models with up-to-date data, and make sure our models evolve in time with new and updated data that we collect. So I will present 4 tools. 2 of them will relate to the label validation task, meaning labeling in production. Then I'll talk a little bit about using multiple annotators for the data. One tool that is useful for label validation evaluation, in case we have an item that is going through the model and then also reviewed by an annotator, is to understand the contribution of the annotator to this system. We will count the number of items where the annotator was correct, and we subtract the number of items where the annotator was wrong, but the model was correct. We divide that by the total number of items. We will get the robustness index that actually quantify the contribution of this annotator, and we will get a number between -1 and 1. Examples. For example, we have 3 annotators here in the table. We can see the robustness index we calculated for one of them is actually negative. This means we have a negative contribution for this annotator to our system. And we probably should remove this annotator from the task and disregard the labels that he changed or approved. The other 2 annotators, the 2 lower rows in the table, are a positive robustness index. This means we have a good contribution of the annotators in this case, and we can also compare them and compare each annotator with others and also with themselves in different times. Notice that for robustness index calculation, we only need to audit or label the labels where the model and the annotator are not the same. And then we can get the robustness index and decide how we approach. Should we retrain the annotators? Should we remove some annotators from the task? So it's very indicative in that sense. An additional tool is using selective annotation. Let's see some examples in order to understand what I mean here. We have 5 examples here. You can see the ground truth. Let's say it's a sentiment, and it can be positive, neutral, or negative. So each item has its ground truth. And then we have the model prediction and the model confidence of that prediction. In addition, we have the annotator label. So in this case, the model accuracy is 40% and the annotator accuracy is 60%. What if we decide the annotator will only annotate below a certain threshold of confidence for the model? Let's say in this case, we choose 0.65. If we choose 0.65 and we take the model labels for above that and the annotator labels for below that, we will actually get a combined accuracy of 80%, which is higher of the model accuracy alone or the annotator accuracy alone. In Zencity, we did that, and we saw 2 different behaviors. In one model, we saw we get to a certain plateau. So on the left graph, you can see the combined accuracy versus the model confidence threshold. So for different model confidence threshold, we got different combined accuracy. And at some point, we got to a plateau, meaning the annotator's contribution from a certain model confidence is 0. They annotate, but we don't gain any accuracy from that. On the right side, you can see there is some peak in that graph, meaning that from a certain point, the annotators actually hurt the combined accuracy. So we better have a certain threshold in each of the cases. And if we choose these thresholds and we annotate only below these thresholds, we will actually get a better accuracy as well as saving time and money for annotation. So these are the use cases we saw on Zencity, and we were able to act upon them. So we talked about robustness index. We talked about selective annotation, which I just presented. let's talk a little bit about using multiple annotators to infer true label. We know that creating high quality data set, which is labeled in a robust and reliable way, is time consuming and it's expensive. If we use a single annotator, we're more likely to get poor quality. A very common approach today is use crowdsourcing and send our items to annotators all over the world to annotate our data. Then we can aggregate all of their labels and get the ground truth. It's very common to aggregate the crowdsourced labels by using majority voting. And the problem with majority voting is that it doesn't take into account how good is each of the annotators, or if an annotator performance is changing over time. We don't know that. It can be good when we tested him, and then the accuracy can decrease. So majority vote doesn't take that into account. If one annotator is better than the other, we don't know that in this case. What does it mean? So in this example, let's say we know the annotator's chance to be right. We have 3 annotators. 2 of them have 60% chance to be right. The third one has 80% chance to be right. The label, the 2 first claim is tiger, and the label, the third one claims is cheetah. If I'm using the majority vote approach, I will say, let's go with tiger. Tiger is my final label. But if I'm using the probabilities here, and I multiply them using Bayes rules, I will see the tiger probability is actually lower than the cheetah probability. The tiger probability will be 0.36, while cheetah probability is 0.64. But I don't really know the annotator's chance to be right. So how can I do that? We can use an algorithm called Dawid-Skene aggregation, which originated in 1979, and since then has developed and evaluated in different ways. It's very popular for crowdsourcing aggregation, and it can help us infer the true label from these multi-label that we get from different annotators. What this algorithm does is using expectation maximization algorithm. It maximizes the likelihood function of the observer error rates, which are actually the accuracies of our annotators. So this iterative algorithm learns the worker skills, their accuracies, and their chances to be right, and can also tell us the final label according to these accuracies. Practically, the way to try and use the Dawid-Skene algorithm is a Python package called PyAnno, which we used in Zencity. It offers 3 probabilistic models of data annotation. One of them is Dawid-Skene. The output, as you can see in the slide, can be the estimated accuracy for each annotator, as well as the Dawid-Skene label after incorporating these probabilities. On the right, you can see an example of how to use this package code. So we import the PyAnno model, create an initial model by defining the number of classes and the number of annotators. Then you just run the model. You estimate the probability distribution of each of the annotators' accuracies, and using this distribution, we can sample from it and just get the accuracy itself of each annotator. Then we can, by using infer labels, we can calculate the probability of each of the labels for each of the item and just take the maximum one. This is the Dawid-Skene label. So we saw how we can also use multiple annotators, infer the true label, and estimate the accuracy of each annotator. In Zencity, we were able to use the data-centric approach and leverage our models and improve the performance. So one interesting use case that we had, one of our sentiment models was performing pretty low and we wanted to improve it. We tried different models, different architectures in our network. We tried to use transformers. We were able to improve our model, but the improvement was very limited. Then we took a step back and we thought, what else can we do? Let's look at the data. We had a large data set that the model was trained on, but the quality of the annotators was diverse and the guidelines weren't that clear. So we thought, let's just create a new data set. It was smaller, but we focused on data that is relevant to our system. It was very product oriented. We used popular items and items that are very relevant in our system. We used multiple annotators. We had a better training sessions and we monitored their performance. We used smart aggregation in order to get the true label using Dawid-Skene. And just by doing that, we were able to improve the model performance by 10%. So we leveraged the data without changing anything in the model. So my main takeaways from this talk is to be data-centric and know your data. If you are doing label validation in production, meaning you have annotators labeling to review and assure the correctness of your labels, be data-driven to improve the user experience and make sure you know what happens in that system. If you're using multiple annotator for smart aggregation, make sure you're using the correct and the best fit algorithms for you for the aggregation. And make sure you know the quality of annotation of each of your annotators in different times. So that's what I wanted to share with you today. I hope you will be able to use that. Some useful links in the last slide, and that's it. So thank you very much for listening.